So we already talked about how daylight could be or is a sinusoidal occurrence in nature. Another common thing that we discuss when talking about sinusoids is temperature. So we're coming into the fall. What's happening to our temperatures? Maybe not fast enough for some of us, like myself, but what's gradually happening to our temperatures? They're dropping overall. And then when we hit about January, they kind of bottom out. And then they start to warm back up into summer, and then they peak in the summer, and then the whole thing starts all over again. So that is a sinusoidal pattern. So that's what we're looking at here. We have a table that represents the average monthly temperatures in Helena, Montana, shown in the table below. Graph the data and write a sinusoidal function of time using 20 as the minimum value and 68 as the maximum value. Month 1 is January, month 2 is February, etc. Okay, so if I'm going to graph this, what should my x-axis represent? The temperature or the month? The month. And then the temperature I'll put on that y-axis over there. Okay, so let's label this months, or month. Okay, now I have to go out to December, right? Or 12, which will represent December. I'm just going to go ahead and put that mark out there. And I've got to fit 11 more in there. So what I usually try to do is I'm going to try to find the middle. That would be 6. And then the middle of that would be 3. And then I can split those evenly. Makes it a little bit easier sometimes to get 12 sort of evenly spaced little spots there. Okay, so I could put 1 through 12, but what I'm going to do is just put the letter for the month. So I'm going to say January, February, March, April, May, June, July, August, September, October, November, December. Okay, so let's look at the high and the low. So the highest temperature that I have, okay, y'all stop and think about this. We're in September right now, which is the 9th month. Look at their average temperature, 56. That sounds amazing right now. It's supposed to get up to 90 today here to give you a little point of reference. And their average is 56. Of course, they're a lot farther north. Their hottest month, July, average 68. That's not even 70 degrees for the average. That's awesome. I mean, it doesn't mean that it doesn't get above 68, right? Probably gets about 75, but then in the 50s at night or something like that. And then also 20s in January. That's pretty cold for the average. That's very cold for the average. All right, so here's our lowest, 20. Here's our highest, 68. How should I scale this? It's a pretty big difference, isn't it? And often what we do is we'll just do like a little squiggle. Like, I don't need anything below 20. So I'm just going to say, okay, here's 20. I'm going to start at 20. But I have to go up to 68. Let's just say 70. How should I space this? It didn't give us a whole lot of room, and we could go higher if we need to. Maybe by 10s. So let's go 30, 40, 50, 60, 70. Okay, then I'm going to label it. This is the temperature. Because if you don't label your graph, it's kind of meaningless to look at it. Okay, so what I'm going to do next is take these values in the table and just plot them. Now, of course, I'm going to be guessing on some of these, but as well as you can, let's plot 120, 226, so 2 is February, of course. March is 3. If you want to put like January, February, March, April, May, June, July, August, September, October, November, December across the top, just so you don't mess up. Okay, I'm on March, and I'm going up to 35. April, 44. Okay, so once we get the points, then we'll connect them. I mean, they should look like a sinusoid, right? So it's not going to be an exact sinusoid every single time, but it should represent a sinusoidal nature. Now, this is going to keep occurring, right? So I could actually just sort of curve that back up, and I'm going to curve that back up because those temperatures aren't going to keep going down. They're going to turn when we get back to the next January and February and start heading back up again. So here is my curve. Now, it doesn't look like a sine curve like that, but it's like we took a little piece of this graph, right? Or it's like we took a little piece of a cosine curve. Okay, remember, cosine looks like this. It's similar to that right there, isn't it? With one exception. It doesn't start at the max, does it? It starts at a minimum. So it's like I have this little chunk of curve right there. Okay, so I'm going to treat it like it's a cosine curve that's been shifted a little bit. And it's not starting up, it's starting down, so I'm going to say it's a negative cosine curve. Does that make sense to everybody? Because I'm starting at a low value. Now, what if I'm in the southern hemisphere where December is summer? Wouldn't that be so weird? So if I'm down there in southern Australia, then I'm going to start at a max value, and so that would actually be a normal cosine curve. But this one is reflected or flipped over the x-axis. Okay, so I have everything graphed. Now we have to figure out how to write a function. Okay, so as I already said, I'm going to use a negative cosine curve. And that's because starting at lowest values. If it was starting at a maximum value, then I would use just a normal cosine function. Okay, where's the center line of this function? It's not on the x-axis, is it? Okay, so if the center line is not on the x-axis, that means I have a vertical shift. How do I find where the center is? If you had 2 test grades and you wanted to know your average, wouldn't that represent the grade in the middle? Okay, so how can I find that average temperature? I could add them all up and divide by 12, or we can just take the max and the min and do the same with that. Okay, so that's what I'm going to do, kind of like a little shortcut. Okay, so for the midline, I'm going to take the highest and the lowest and average them. Okay, so that's 140. Oh, no, it's not. That's 88. Divided by 2. Where did I get 140? Which is 44. So 44 degrees is the midline. I'm going to go up here on my graph and go to about where 44 is. Does that make sense that I'm oscillating over and under that line? Yeah, it looks like it goes through the middle of the curve-ish, right? Okay, so this is going to be my H value. That'll be my vertical shift. It's not centered on the x-axis. It's been moved up, centered around 44. Okay, if I know this center line is 44, how can I find the amplitude, that A value? Yeah, exactly. I want to know how far this is, and that's my amplitude. Okay, so take your highest. Amplitude equals the highest, which was 68. Subtract that midline, which was 44, and that will give me 24 for the amplitude. That's A. Okay, so I have A and I have H. I just have to find K and C, and we're done. And in addition to using 24 out front, remember I am going to make it a negative because it's starting at a low point, not a high point like cosine normally would. Okay, so who has that dissect the sinusoid thing? Let's see, I might have one handy. Who has one handy for me? Let's see if I can beat you to it. Here, I got one. Okay, remember K and C, K here, C here, they affect the phase shift and the period. So I'm going to use this down here, the fact that the period is 2 pi over K, as my formula. So I'm going to say period equals 2 pi over K. All right, I don't know what K is. That's what I'm looking for. K is the coefficient that goes in front of the x or theta. What is the period of this graph? How far do we go on this graph before this pattern starts to repeat? 12 months. Every year, this whole pattern is going to start all over again. So I know that the period of this graph is 12 months. So I'm going to say 12 is 2 pi over K. Now that's 12 over 1, right? I'm going to multiply both sides by K, or you could say you're cross multiplying. And I get 12K equals 2 pi. Well, I'm solving for K, so I'm going to divide by 12. And that gives me K equals, what does 2 over 12 reduce to? Okay, so I get pi over 6. That's my K value. Now, something that's an annual pattern, like daylight, temperature, the period's always going to be 12 for something that's an annual occurrence. Okay, so the only other thing that's missing is C, and we're going to use this formula, phase shift equals C over K. Phase shift equals C over K. Well, I just found K. So I know that I have C over pi over 6. Okay, what is the phase shift? This thing is not at a minimum or a maximum above 0. It's at a minimum at 1, month 1. So I'm going to say this has shifted 1 to the right. So this phase shift is just 1. And anything that's going to start at 1 month, first month is January, will have a phase shift of 1. Okay, so I'm going to solve this for C by multiplying both sides by pi over 6. And those cancel. And 1 times pi over 6 is just pi over 6. So I have C is also pi over 6. Now, because it shifted right 1, I'm going to use a minus in front of that C value. Okay, so once I have A, K, C, and H, then I can put it all together in my equation. So here we go. My equation is y equals negative 24 is because it's starting at a low point, not a high point. It's been reflected. Cosine k times theta. K was pi over 6 times theta. Minus c. Minus goes right, so minus c was also pi over 6. And then plus h, and my h was 44. That is the equation that models this temperature. Okay, now let's test our model. Let's see how accurate it is. The little calculator here. Okay, what I'm going to do is put my calculator in radian mode. Mode radian. Okay, and let's say that I want to test the accuracy of this for March. Okay, what month is March? January, February, March. It's the 3rd. So I'm going to enter this equation, but in the place of theta, I'm going to put 3. Okay, so I'm going to have negative 24 cosine pi over 6 times theta. Well, for March, that's the 3rd month, minus pi over 6, close it, plus 44. And the prediction is 32 degrees for March. And if I look up at my graph, or my table, that's pretty accurate, isn't it? I mean, it's not spot on, but again, this is an approximation. From year to year, it could change slightly. From month to month, it could vary, not really necessarily go with the norm. But I'd say that's a pretty accurate equation that we found. Who's in the ballpark accurate? Question? All right, let's do this one. Okay, so now we're moving to Buenos Aires, Argentina. Which hemisphere are we in now? Southern hemisphere. Okay, so should be slightly different. Whereas Montana started out coldest, Buenos Aires is going to start out at its high because in January it is summer. So weird. If you've grown up here, that would be weird. I'm sure our weather would be weird to them. Okay, so same situation. I need 12 months along the x-axis. So let's label those. Okay, not as much variation in their temperature. The minimum is 52 and the maximum is 77. Okay, so how should I scale this? What should I start at on my y-axis? 50, I think would be a good place. So I'm going to do a little squiggle. We're starting at 50. I thought we could go by 5s. What do you think? Let's try it. I may have to extend it a little bit farther up. I guess really I should say average temperature. Okay, so once you get your graph set up, now start plotting your points. And then connect them when you are done. about yours, but mine looks a little bit better than my last one did, I think. Okay, can you see that this curve does not match the sine curve as well as it matches the cosine curve? It's starting at near the highest point, whereas the other one, that's why we used a negative cosine, it was starting at its lowest point. Okay, so what was the first thing we did previously? What do we do on the other side? First, we found the what? Midline, or sometimes we call it the center line. Okay, so we do that by what? Average the highest and the lowest. Okay, so midline or center line will be highest plus the lowest divided by 2. Some of these we're going to get little decimals. Let's see, that's 129 divided by 2. 64.5. And that will represent what in my equation? Which is what in the terms of these variables? H. Now, notice on this I said T equals just because it was temperature. I didn't. Oh, yes, I did over here. You could also just use Y because temperature is what the Y-axis represents. Okay, so once I found the midline, which is about here, okay, so that seems pretty accurate. That runs about through the middle there. I can either find the amplitude by subtracting the midline from the highest, or subtract midline minus lowest. I should get the same thing either way. So figure out your amplitude for me. What you get for your amplitude? 12.5, I agree. And so that is our A value. Okay, so I will use a cosine. Oh, y'all. Can you figure out, see what I left out on this? I didn't notice it on the previous page. I don't have sine or cosine on there, do I? Oops. Cosine. I need to add that to it. Okay. Cosine. I need to go back in and change that. Okay, so this will be a cosine function because it's starting at its highest, but it is not reflected, so I don't need to use a negative. Okay, I found the H value, I found the A value. Next, let's find the K value, which is reflected in the period. So if I say period equals 2 pi over K, but what is the period of this graph? How long before this graph repeats? 12 months. So 12 equals 2 pi over K. Multiply both sides by K. 12K equals 2 pi. Divide by 12. And K equals pi over 6. Alright, next, the last thing we have to find is the C value. So I'm going to use phase shift equals C over K, the formula that's at the bottom of this sheet right here. And I just found K. How much is this graph shifted? It's not at a max over 0, it's at a max over month 1. So that shift is 1 equals C over K, which is pi over 6. But if I multiply both sides by pi over 6, then I get C equals pi over 6. Now this is shifted to the right, 1, so it will be a minus for our C value. Okay, let's write it up then. My equation, putting all that together, is, I'll use t this time since I did it up there. My amplitude comes first. It's a cosine, not a sine curve, but it's still called a sinusoid. K, pi over 6, theta, minus c, because it's shifted right, and then plus h, 64.5. Question? The amplitude, once I found the midline, then I figured out how far that was from the lowest or the highest minus the midline. Either one. Any other questions? All right, that's it. Let me give you your assignment and get started on it. 2 problems for homework.